Hi everyone, in this video I want to walk through an example and just start working on understanding what the definite integral notation is looking for. So I've given you the graph of this function, and let me just make sure this is really easy to spot. This is my x-axis. This is my y-axis. Okay, so the first thing that we're asked to do, very first thing, is just an area question, and then we'll get into it a little bit more and start to pick apart how that's different from a definite integral question. So the first one wants to know the total amount of area trapped between the function and the x-axis. So I'm looking for any areas that are bordered, that are bounded by the curve f of x and the x-axis, which means I'm going to get this chunk of area right here above the axis and this chunk of area right here below. If I try to start picking out other sections, say here or here or here, you're not going to get finite area. There's nothing to close it in that is one of our bounds that's either part of the function or the x-axis. Okay, so if we want to find the total amount of area, you can do this however you want. You can count squares. I like to break it up into nice pieces. So this piece right here is, oh, I scribbled so much that I don't know if I can see my, I think this was 6 high. Here, let me erase my mess. Yep, by 2 wide. So it means that that total area is 12. This little piece right here has a base of 1 and a height of 6. It's a triangle, so we have to do half of 6 times 1, so that's area 3. This is an identical little triangle down here, also area 3. I'm seeing in the middle here a rectangle that is 6 by 1, so area 6. And then last but not least, this went from 5 to 8, so this has a base of 3, a height of 6, which means this is half of 6 times 3, half of 18 is 9. So if we add all that up, that's totally going to be in my way. Let's see, I had the 12 and the 3 is 15, plus 3 is 18, plus 6 is 24, plus 9 is 33. I think I added that all up right. 9, 9, 18, 28, 33. Yep, okay. So the total amount of area trapped between the function and the x-axis is 33 square units. Now I want to look at some definite integrals and figure out what exactly they're asking me to find and how that differs from what I just did. So the first one, integral from 0 to 1 of f of x. So this is asking me to find the area trapped between the curve and the x-axis just on this interval 0 to 1. Okay, so there it is. The area of that rectangle is 6 times 1, just 6. So nothing too weird going on yet. Next one, let me see if I can figure out what order I think I meant to go in. I think I meant to work my way down. Now let's go from 0 to 2. So I'm just going to stick with green for now because nothing too weird is going on. So same idea, but I've made my rectangle a little wider. So now the rectangle is 6 by 2, which is 12, meaning the definite integral should have value 12. So again, we're still in the part where this is all just matching up with area, nothing weird so far. If I want to go from 0 to 3, I'm going to add this little chunk. So now I have my 12 and then the 3 that I got before. So 12 and 3 is 15. Still nothing too weird. 4 to 5. Okay, now I think we're going to finally get to some of the weird stuff. Let's see if I can pick a blue, not too dark. Okay, so if we want to go from 4 to 5, we are going to get a rectangle, but here's where it gets a little bit strange. The definite integral is just a limit of Riemann sum. So if we think about the Riemann sum that's going to go on between 4 and 5, we're going to get the area of any of the little individual rectangles by taking our delta x, which will be some small positive number, and multiplying it by the height of this rectangle, which comes straight from the value of the function. So even though we're calling it height, we're thinking it area, the definite integral, the Riemann sums and the definite integrals will not count that as positive. They will say, okay, I have a positive width and a negative height. And so when they do the whole, when we do the entire section, what is this, down to -6? So we will get that the area of that rectangle is 6, but the Riemann sum will absolutely say that that means the value of the definite integral is -6. So really, a definite integral isn't just area, it's the sum or difference of signed areas. Any area above the axis will get counted as positive, any area below the axis will get counted as negative. Okay, so now we've looked at all above the axis, all below the axis. 5 to 8, I think that's actually another all below. We have another good color. Let's use this. Okay, so if we're going from 5 to 8, that's this chunk right here. And we know that the area of the triangle was 9. Once again, since it's below the axis, the f of x part of this, so we're taking an f of x multiplied by a dx. The dx's are positive, the f of x is negative, which means it is going to count that as negative. So again, area is not negative, but integrals can be. Integrals are sums and differences of areas, so subtract areas below the axis. Okay, 0 to 5, here we go. Now I think we finally get into one. I'm running out of colors. Let's do, where do purples live? That is not where purples live. There's a purple. Okay, so let's do purple. So if we're going from 0 to 5, we're going to start at the y-axis. I have so many scribbles. 2, 3, 4. Okay, so we're going out to here. So I want this top area. And I want this area below. Okay, and again, the integral isn't going to add those two together, it's actually going to subtract. So it's going to take the area up above, which is 12 plus 3, and then it's going to take the area down below, which is 3 plus 6, and it's going to subtract. So I have 15 units above the axis, I have 9 units below the axis, which means when I add and subtract, when I take the 15 minus the 9, I actually only get 6. So if you have areas above and below the axis, they can cancel each other out. So interesting thing to note, I'm not even going to say it because I think I'm getting ahead to what I was going to say in the next one. Okay, hold on, let's see if I can erase some of this mess and make this more visible. Yay! Okay, so for the last part, what do we want? Let's go red. We want to know what happens when we integrate from 2 to 4. So again, here's the axis. We're going to get this little triangle above. It has an area of 3. And then we're going to get this little thing below, triangle below, which also has an area of 3. So we know that we've trapped a grand total of 6 units of area, but the integral is going to take that as area above the axis 3 minus area below the axis 3, and it's going to say 0. So the integral being 0 does not mean we've captured no area. It could potentially mean that we have captured areas, but there's an equal amount above and below the axis. Okay, so this is what happens when we start talking about definite integral. So I think a lot of this graphical idea should be really easy, I hope, but the thing to be aware of, the tricky detail, is that we have signs associated with those areas. All right, thanks for watching.